Hey everyone, it's Dr. Jess. Welcome and welcome back to my channel. In this channel, we cover topics from chemistry to pharmaceutical calculations and pharmacology. If you like these types of content, please like the video, subscribe to the channel, and turn on your notification bell so you don't miss out on any new uploaded videos. In this video, we're going to discuss how to use the Lewis structure and electron group to predict the shape of molecules. Okay, let's get started. We can use the Lewis structure to predict the three-dimensional shape of many molecules. So first, you should draw the Lewis structure and then determine the number of electron groups that are around the central atom. Now, if you need to learn more about how to draw Lewis structure, check out my video on that topic linked in the description box. Okay, so let's talk a little bit more about electron groups. So when we say looking at the number of electron groups around the central atom, so a lone pair is considered one electron group, a single bond is another electron group, a double bond is one electron group, and a triple bond is one electron group. Okay, so let's look at an example. So let's look at the Lewis structure for carbon dioxide. So on the right hand side, first line. So the central atom here is what? So it is carbon. So how many electron groups do you see around the central atom? So around carbon. So here there's two electron groups, right? So there's two double bonds. Okay, so how many atoms are bonded to carbon? There's two atoms. Do you see any lone pairs? No, there's no lone pairs. So the geometry and the molecular shape for carbon dioxide is going to be linear. Okay, so let's look at an example now with a molecule with three electron groups. So formaldehyde. So let's look at the second line on the right hand side. So that's the Lewis structure for formaldehyde. So how many electron groups do you see around the central atom carbon? So there's three electron groups here, two single bonds and one double bond. How many atoms are bonded to carbon? So there's three atoms bonded to carbon here. There's no lone pairs. So the geometry and the molecular shape for formaldehyde is going to be trigonal planar. Now let's look at another molecule which also has three electron groups, but then we'll see how the molecular shape is going to be different than formaldehyde, and we'll see why. So let's look at sulfur dioxide, SO2. So sulfur, that's line 3. So sulfur here is the central atom. Okay, so sulfur is the central atom, and how many electron groups do you see around sulfur? There's three electron groups again, but they're different than formaldehyde. So there's one single bond, one double bond, and a lone pair. So the difference here, there's only two atoms that are bonded to sulfur, oxygens. So although the geometry is still going to be trigonal planar because there's three electron groups, but the molecular shape is going to be bent because there's two atoms bonded here and one lone pair, versus formaldehyde, there's three atoms bonded and no lone pairs. Okay, now let's keep going. So let's take a look at molecules with 4 electron groups. So first let's look at CH4. If we look at that molecule, what is the central atom? So it is carbon. How many atoms are bonded to carbon? 4. So there's 4 electron groups, 4 atom bonded. So both the geometry and the molecular shape are going to be tetrahedral. Okay, now let's look at NH3. So NH3 is going to be different, although there's still 4 electron groups, 3 single bonds and 1 lone pair. So now there's 4 electron groups, but only 3 bonded atoms. So the geometry is still going to be tetrahedral, but the molecular shape is going to be different. So the molecular shape is going to be trigonopyramidal. Okay. Now let's look at another molecule with 4 electron group, but again the shape is going to be different. So if we look at water, H2O, we see that there's 4 electron groups around oxygen, right? 2 single bonds and 2 lone pairs. Okay, so how many atoms are bonded to the central atom? 2 atoms, but there's 2 atoms bonded in 2 electron pairs, so that two lone pairs. So total it's 4 electron groups. So the geometry is still going to be tetrahedral because there's 4 electron groups, but then the molecular shape is going to be bent. So if we look at everything we just went over, we can see how for CH4, NH3, H2O, all 3 molecules have 4 electron groups, but they all have 4 electron groups, so their geometry is tetrahedral, but their molecular shape is different. Why? One of them has 4 bonded atoms. The second one has 3 bonded atoms in 1 lone pair. The third one has 2 bonded atoms and 2 lone pairs. So that's very important. So the electron group is important to tell you the geometry, but you also need to look at the how many bonded atoms versus how many lone pairs to see what the molecular shape is going to be. Okay, that's it for today. Please don't forget to like the video and subscribe to the channel on your way out. I'll see you in the next one. Bye!